Hi Rahul.
Hi, sir.
So, what is this project you are giving? Project plan document here.
This is project fund document regarding the FinTech risk scoring engine, AI solution architecture level design means designing document designing, and this is a FinTech agent, AI agent, risk scoring agent, and for
Can
the
you discuss first the requirement? Why you are choosing this Agentic AI? What is the situation in the project? Yeah.
business in fintech industry. So major problem regarding the fraudulent pattern. So in traditional credit scoring system, what happen in fintech heavily depend on the static machine learning models or rigid rule-based engines to find out the who will be fraudulent on particular uh, using particular trends or past histories with the help of data. This system often fail the adapt the real time because the system are trained on the limited data, cannot handle the real time situation. So in now current industry scenario, what happen around 80% of data is unstructured. Machine learning model cannot handle the unstructured data. So struggle with this new evolving fraud detection pattern cannot be handled. This led to the inaccurate credit scoring, delay in decision making, and high number of false positive in the fraud detection. So goal of this agentic AI fraud detection, agentic AI development of this agentic AI fraud detection to autonomously process transaction and behavior data and reason over a customer financial history and detect the anomalies in a real time and continuous adapt based on the feedback, and this system will improve the risk prediction and enhance the fraud detection, and this enhance it reduce the manual investigation workload. Ultimately it help banks also in fintech companies also, and it help in a better customer experience. So this is a business problem, sir. So, so now so to build this AI agentic AI engines, risk scoring engine, we are going to use these technologies. First, the LangChain, RAG, MCP, Model Context Protocol, Azure, then LangGraph for the and LangChain for the agent calling, RAG for the contextual reasoning, MCP for the explainability and auditability, and Azure Cloud for the ADF, blob storage, Databricks, Azure ML, OpenAI for retrieval. So all these are the key components, and Power BI for the dashboard creation. So all these technical stack we are going to use in these particular projects. So this is the overall what skill are used or with the help of what skill we are going to build these projects. I'll explain. And then next is this is the overall flow of the projects. First, I zoom it. So here you can see as the data come from the external data source SQL or CSV format. Then it is a uh, batch injection and real-time injection also. And then it come to the Azure Blob Storage. Then database trigger with the help of ETL. We perform feature engineering and then train the model using Azure ML. And here also store the all the data in a vector format because we have to perform the querying on that particular vector database with the help of OpenAI API key. Then after this model registry or evaluated model, go to the line graph for the future with the help of line graph, we can call these particular models. And with the help of line graph, we can, because this is a line graph is a graphical representation of flow. With the help of this, we can call the multiple agentic AI tools inside the with the help of that nodes and edges that present in a line graph. And after that, we can get the all the results we are from the Azure API secure. We can give the risk score summarization with the help of line graph. We can send the alert also, notification also, any fraudulent happening on the real time. So these are the overall what outline of this particular projects. And MCP tracks also using the Azure blob and database logs and link to the Azure database, Azure data linkage. And then it's again this data linkage go to the Azure blob, and then when new happening, because it is a catalog for the memory purpose, and then same process going to do again. So this is the overall data flow of the this particular projects. So now I explain the business problem also. Now I go to the next stage, that is agentic AI value preposition. Unlike traditional model that act as a single shot prediction models, it will predict like is particular client default or not, it is trustworthy or not. This is a short-term legacy practice using a model, unlike traditional model. But the agentic AI system can automatically plan, use tools with the help of LangChain. We can call different tools, ML models, vector database, and recall the past user behavior also, and adapt the approach based on the result. For instance, if agents see unusual spending behavior on the by particular customer or client, cross. So it will is, raise the alert message. So that fraud, there is a high chances of fraud can be happen in real time. So it will be help in saving time, reduce false positive, and improve decision quality. This approach is practical, powerful in fintech, where risk scoring depend not only on numerical credit data but also behavior, transaction, and often semi-structured input and the vector database. So these are the overall outline of that particular project. This is what is a business problem and how we can going to solve with the help of agentic AI this problem in real time. So to solve this problem, there are the seven sprint in from here. So this project is divided into seven sprint from POC data preparation to the lastly data project deployment using the AKS, Azure Kubernetes Service, and lastly QA testing and retrospective analysis also I have done here. What will be issues can be arise and how can we challenge, improve, and how can we improve and recommendation for the future purpose. These also I am showing in this documentation. So now first go walk through the first, that's Sprint 0. Spring Zero is regarding the data preparation. Here, prepare synthetic customer data to build the foundational knowledge document for the RAG integration. So, in that particular sprint, task is creation of the data set, and they can clean the data set, detect the anomalies, generate the fraud pattern using synthetic data value. This can be done with the help of Python. We can install the library and generalize synthetic fraud pattern. Then anonymous fields, create policy, convert knowledge base to a vector ready format, and upload clean data from knowledge base in the Azure Blob Storage. So these are the first phase. In this first phase, what we are going to do, and delivery, what we are going to happen, clean data set. This clean data set we get. So here what tools, pandas, SDB, Azure Blob Storage, and LangChain document loaders we can use in this first phase of Sprint 0. So this is the overflow data flow diagram. Data flow diagram here I show here to you, and his data flow diagram. Now I run the initially. Now I take this prompt, run this prompt in DeepSeek. So these are the prompt I am giving you. You are act as a fintech, agentic, LangChain, RAG, MCP, Montes Control Protocol, other database architecture. You are tasked with helping me design, develop, and document modern agentic AI-driven risk scoring engine for fintech application. The system should be built using the following technologies like LangChain, LangGraph for agent orchestration, RAG for the contextual reasoning, MCP for explainability and audibility, and Azure Stack means I'm going to use Azure service here. The like ADF, Azure Blob, Databricks, Azure ML, OpenAI, Power BI, Azure AKS. So many more service in Azure I am going to use. So now DeepSeek give the system memory regarding core architecture component. Here architecture orchestration layer, LangChain and LangGraph implementation is stage. Then here is the how we can with the help of LangGraph, how can we add the different agent, call the agents, then RAG implementation, and then MCP integration with the MCP protocol and Azure data pipeline here. So, and score model architecture, traditional ML model and LLM based model with the help of Azure ML and with the help of Azure OpenAI. And this is the with the help of this model, we going to call the model and we get the final result. So this is the roadmap. First, foundational core engine optimization, and lastly, monitoring and governance. So now back to the this our architecture document. After completion of phase Spring 0, there is Spring 1, a real-time batch injection pipeline. Inject both batches, means real-time and static data also. So for low latency purpose. Goal to define ADF pipeline, configure Azure Event Hub, upload ADF to process both batches and streaming input, store the raw data in blobs and trigger Databricks notebook and pre-process the data. So from this, what we will get? Pre-processed data, ADF pipeline, raw batch streaming, zone in blob, and secure credentials set via keywords. So here what tools? Azure Data Factory, Azure Event, Azure Blob, and Azure Keyword. And this is a overall flow of the uh, uh, data flow diagram for the Spring 1. So here you can see the Azure batch pipeline. It's a batches come triggering happening here, data validation, then data is go to the database for processing, and then the data is going to string, and then again going to store in the Azure blob. So these are the overall structure of the this Spring 2. Then Spring 1. Then Spring 2 is feature ETL and feature engineering. With the help of Databricks, we are going to perform the feature engineering to get the high quality data, clean data. So, and the after getting the clean data, we are going to store this data in a vector database also. And for this purpose, we are going to use tool Azure Databricks, Data Lakes or Data Lake for the storing, feature tool, Sentient Transformer or Azure OpenAI for the embedding purpose. To make the embedding, we are going to use Azure OpenAI. So here we can see the data flow diagram, Azure blob storage, raw data in the Azure Databricks, load data, then we are going to perform the feature engineering, then pre-process the data and store in the data lake with the versionized storage. And also text data, we are going to perform the embedding on this text data and going to store in a vector database. Then sprint 3, model training and drift monitoring. So here we are going to train our machine learning model with the help of the algorithm, XGBoost or Light GBM. So split the data into train, test, split. Then after training the data, we evaluate the data. We evaluate the matrix with the help of F1 score AUC, and then accuracy also we are going to measures after they register the best model in Azure ML Studio, and schedule the weekly draft check using the evidently AI. after what will we get? We get the credit model dot pickle file. In the pickle file format, we get the train model, and their artifacts are shown in a JSON format. So this is the data flow diagram for the training the machine learning model. Azure Blob Storage, then it will go to the Azure ML Studio where data splitting is happening. With the help of this machine learning model, we are going to train our model. Then model output in the format of accuracy, F1 score, AUC, or root mean square values. Then store the model, train model. Then also store the ML model registry also in, and then after this we are going to perform the means model training. Here we can feature importance with the shape explanation, then model chart credit in store in the JSON format, and this JSON file we are going to store in Azure Blob Storage. Here we can perform drift report also, and automate. Here we can use the two approach, auto ML and or normal approach. With the help of Python coding also we can train the model and store all the artifacts drift into registry. Then Spring 4, here Agentic AI layer and LangGraph. To build the intelligent agent pipeline that use tool drag and make decision. With the help of LangGraph, we are going to define the flow of the Agentic AI, build the LangGraph tools. Then with the help of LangGraph architecture, we are going to call the different tools. With the help of Langsmith, we are going to debug our Agentic AI model. And on the indexing, we are going to store all the data in a vector database like FASI or Chroma. On that database, we are going to perform the querying and get the real-time information. Sir, here we are going to use a tool LangChain, LangGraph, a vector database like Chroma, FASI, or Azure OpenAI, and Langspeed for the debugging purpose. Our model debugging purpose, we are going to use Langsmith. So these are the DF data flow diagram. Azure blob storage, then blob storage, it will be going to the FASI, Chroma, then vector store, then with the help of the LangChain tool, we are going to the extract data with the help of RAG from the vector store and get the then this will LangChain credit score tool, predict risk score tool, credit rows predict, and with the help of LangGraph, we are calling this particular tool and get the output in the query or summary format. For the tracking on this, we are going to use Langspeed the export for debugging and show the flow of there is any error occurring on that particular flow or not. With the help of Langspeed, we are going to watch on that particular workflow. After this Sprint 5, we are going to perform API integration, explore the agentic AI pipeline as a secure, scalable. We can use REST API service. Task to with the help of post method, we can send the method, then accept the customer profile input using JSON format. Ready full response including credit score, fraud risk, JNA summary, and MCP tracks. Containerize this all system we are containerized with the Docker and then deploy on the AKS Azure Kubernetes service. Then deliverable, there's a main.py. There is all the Python code is there. There's a Docker file and deployed fast API endpoint URL. And this is the overall data flow diagram. In this tool, we are going to use fast API Docker, Redis server, Azure Container App, or Azure Kubernetes service for the deployment purpose. And lastly, last sprint, MCP, data linkage tracking. With the help of Pydantic, we define the MCP schema, log every step in the agent flow, save all the traces to the Azure Blob or Cosmos DB, add the ID or API response, integrate the Azure POU end-to-end data linkage, and visualize using the application insight. Then lastly, with the help of Spring Swan, we visualize the data, summarize the alerts, what we will get the output from the generative OpenAI API key, and we visualize the outputs with the help of Power BI also. So here BI developer roles it comes. So use Azure OpenAI to generate natural language summaries of risk score, integrate it with the API output, build powerful Power BI dashboards. So it will be help in a risk distribution analysis, high risk customer table we can get, and trend fault pattern also with the help of Power BI we can analyze it, and implement drill down capability to view raw transaction and shape value. Allow export full MCP trace for dashboard also. So deliverable risk scoring engine, and then is it with the help of PBIX we can get the Power BI file, and JSON. In the JSON format we can get the alerts, email alerts. So here is the tools: Azure OpenAI, Power BI, and Azure, and here is the data flow diagram for the this process. Fast API, then agentic outputs credit score for MCP track to the Azure Turbo 3.5 train model. Then here from here we can get the summary, GenAI summary. So like this, we store the all the dashboard in a Power BI to the Azure Blob Storage. From Azure Blob Storage, we get the data. Then with the help of Power BI, we visualize the data and share these data inside to the stakeholders. Visualize pattern. And then here we can see the MCP trace JSON also, and here we can see the emails alert with the help of Azure Logic App Alerts. And then final packaging, logs, testing, and the CI/CD pipeline execution. Means goal to finalize the system for demo, production readiness, and reusability. So after the development purpose, we can here we can enable logging and monitoring, package the code into versioned Docker image, and here we can perform the deliverable file, YML file also, and prepare the final reports architecture in diagram, and conduct knowledge transfer and demo in this particular phase. Means final packaging is happening in this particular phase. Lastly, here is the final output. Here we are getting customer ID, credit score, foreign risks, and risks is higher. The summary here with the help of API key. Here we get the summary. Retrieval text also we are given, an alert system also the alert. And then lastly, what will be the retrospective issue identified during the testing? Positive outcome: all core components, data injection, feature engineering, model training were successfully integrated. The agentic AI layer like LangChain and LangCraft demonstrate strong flexibility and adaptability, and API response also within a acceptable limit. Challenges can be faced in this demo. In Spring 4, some agent did not handle edge cases due to the missing data and invalid input. Initially, agent designed to handle security risks due to the allow dangerous code is equal to 2 in the Python code. Then the Spring 5 initial API lacked proper error handling and rate limit, and so for this purpose authentication requires. And Spring 6 logging was inconsistent across the service. Data linkage tracking need more robust integration with Azure Pureview. So here are the challenges and improvement recommendation also here. Improve the agent safety in future, enhance the logging and monitoring, improve the API resilience, strengthen the security, and automate the more testing. Means automate this testing. Agentic AI is important. Only building and testing the get the result, not that is one part, but also testing, QA testing also important. So do automate testing, unit testing, integrated testing. So this is beneficial for the robustness of the agentic AI model. So these are the overall documentation for building the FinTec. FinTec, this is FinTec fraud detection AI agentic AI engine. Yes, sir. So this is
good. So this is the latest modified project information you have mentioned here. In the beginning, we went through different skill sets to include in the project, but later on we have modified it by adding some more modules also, technical modules also,
Yes.
right?
Yes.
Okay. Then next one is your solution presentation, right?
Yes. Yes.
Okay, I'll stop recording.